Hello and welcome to our final video. I'm super excited because finally we get to talk about outliers and get to clean up some of those problems with the age column in our mental health data frame. So we're going to import a few extra libraries to get the job done for us here. But before I get into that, let's just talk about what we're going to do. Essentially, to remove outliers, what we have to do is understand how our data is spread out. So let's look at a quick image I found. This is a normal um, example of what your data might look like. Most of the data is packed around the mean or the middle of your data, of the center of your data. And then we have this measure of spread, or how spread out the data is, which we call standard deviations. Don't worry about too much what that means. Just know that for us, anything that's more than 3 standard deviations away from the center or the mean is going to be considered an outlier. That's why we need these extra libraries here. That's why we need these extra libraries here to help us figure out what's more than 3 standard deviations away from the mean. So let's load in these libraries and load in our survey, our mental health survey. Let's look at the head again, as always. We've seen this plenty of times now. And now we're actually going to drop NAs again on the age variable to make sure we don't run into any issues later on trying to get rid of anything more than 3 standard deviations away. If we have NAs or no null values in our data set, that could cause some problems calculating the standard deviations. So let's get rid of that. Next, I want you to focus on this line here. Basically what we're doing is taking mental health and then taking this age column, which we want to get rid of outliers in, because we've already seen there are a lot of outliers in it in previous videos. And we want to get the z-score, which is like the standard deviation from our stats library we imported up here from SciPy. And then if it's these z-score standard deviations is greater than 3, we won't use it, but if it's less than 3, we will use it. And we're taking the absolute value with this numpy library because we want to make sure it's not more than 3 standard deviations or more than lower than negative 3 standard deviations. We want it to be within 3 on both sides. So let's run that. Oh, and of course we want to see how many rows we're actually dropping. So I'm going to print out the length of any column, just to see how long our data frame is, before and after, to see how many rows we drop. Note that you might also see mental health or data frame name dot shape 0 in other people's code if you're ever reading through someone else's code to find the length of a data frame. Don't worry about that too much, just know that it might show up in someone else's code. But we can stick to what we know over here. So let's run that. It looks like we only dropped 1 row. So let's look at the max of age and see what it is. Looks like that's a pretty big number for someone's age. I don't know anybody who's lived to 300 years old. So, looks like we still have some work to do. Very important concept in data science is domain-specific knowledge, or just understanding of the world. Because we have some domain-specific knowledge, we understand that people don't live to 300 years old. In fact, we can say about anything over 110 is probably a mistake. So what we can do, simply make a mask, removing everything that's everywhere in age is over 110, and then reset mental health to only places where it's less than 110. Now let's look at the max of age again, and we have 72. This seems a lot more reasonable. Now let's look at the minimum value. We have a pretty large negative number, probably a mistake. People usually don't have negative ages. So what we can do is do the exact same thing, but instead we want everything to be greater than or equal to 0. And let's look at the min. And now our lowest is 5. Perfect. So now we have a lot more reasonable values for age and have gotten rid of the unreasonable values that couldn't possibly be correct. Um, I hope you enjoyed this video, and that really brings us to our end of our series on data wrangling and cleaning up our data frames. You're all ready to go now. Go out into the world and do some data cleaning, wrangle some data, and I'm super excited to see what you do. Thanks for sticking around to the end of this whole series. See you around.